So let's move on to the next page. We're going to be starting with example 4 today. Now we're going to be actually using this stuff to, utilize this in some way. So what we just learned, by the way, the last thing that we learned yesterday is called the remainder theorem. And it just states that if you divide a polynomial by a binomial, linear binomial, it's coefficient of 1, value of a, you're actually solving. The remainder is the y value given that x value. So basically, you can figure out a y value given an x value in a polynomial, and that's what we did. That's what we finished up with yesterday. And this is called the remainder theorem. And then we also saw, we talked about this yesterday, but we didn't name it. So the remainder theorem says that if you have a remainder, that is the y value of the function given a value of x. That's what we did at the bottom of the page yesterday. The factor theorem, we also talked about this yesterday. We didn't call it the factor theorem, but we talked about it. We said that if the remainder is 0, then your divisor is a factor of the dividend. And that's exactly what this is saying here. So if you divide a polynomial by a linear binomial with a coefficient of 1, if there is no remainder, then that binomial is a factor of the polynomial. We saw that. We actually saw that with question number 9 from the homework that we just looked at as well. So what we are going to do here is we're going to use the remainder theorem to evaluate a polynomial. So instead of using a value of x and plugging it in here, we're going to use a value of a and use synthetic division. So it's basically just using synthetic division as opposed to plugging in x to the back. Yeah. No, we're not. Because if it says that a is equal to 8, that's a great question. I'm just going to go ahead and a equals 8. I'm just going to draw a line over here, means that the binomial is x minus 8. So x minus 8 is the binomial when a is equal to 8. So we don't have to take the opposite because it's just straight up telling us, hey, this is our value of a. So that x minus 8 is already solved for. The value of x is 8. Okay. So use synthetic division. So we're going to put 8 in our upper left corner. Go and pick up a pencil. Eyes up here. Write this down. Here we go. 8. We are using synthetic division as opposed to just plugging in 8 here. So we're going to use that polynomial. And then we'll talk about what the answer means. Got it? Yep. All right. So what values are we going to write up next to the 8? Good. -1, 6, 12, and 325, because those are the coefficients of this polynomial here. If we were missing, let's say, an x squared, and it was just -x cubed plus 12x plus 325, what would we put here? Yeah, if we didn't have the x squared, what would go here? 0, yeah, because we have to have that placeholder just in case we don't have a value of x for a given exponent. We need to use a placeholder coefficient. So if it's not there, we use 0. All right, let's go ahead and set this up. Bring down our -1. And go ahead and solve this one. Just work through it. Tell me what you get. Yeah. Yeah. Yeah, so you'd have 0, then 0 again. Yep. All right, work through the rest of this problem real quick. Figure out the remainder, if there is one. And then we'll talk about what that value means once we actually, read the rest of this question. So setting it up, we're using the synthetic division process. So let's go ahead and get an answer. All right. What's our remainder? The remainder is 293. Good. So there's our remainder of 293. So if you just go through the synthetic division process, bring down the -1. -1 times 8 is -8. 6 plus -8 is -2. May. Let's write this down. -2 when you add those together. 8 times -2 is -16. Add those together, you get -4. -4 times 8 is -32. 325 plus -32 or 325 minus 32 is 293. Now, what we don't need to do is we don't need to write the answer to the division. We do not need to write -1x squared minus 2x minus 4. That's not part of this problem. If it wanted just the straight up division, the answer as a polynomial, we would, but we don't have to do that because it's not asking us that. What it's saying here is the population of sea turtles nesting on a barrier island is modeled by this function, where x is the number of years since 2021. Use the remainder theorem to estimate the population in 2029. How many years is it between 2021 and 2029? 8. That's the number we have right here. 8 years. So we're basically using a value of 8 for x. So after 8 years, how many turtles are there? 293. So in 2029, there will be 293 turtles. That's our answer. All right. Any questions about this example here? We got 293 turtles in 2029, 8 years later. So what I want you to do next is answer this one on your own. Answer that example number 4 on your own. Take a couple minutes on that. Yeah. Okay. Anybody have an answer? What's the revenue? 285,000? Okay, let's find out. So, what is our value for A in this one?
5.
A equals 5. All right. So we're going to say 5. And then coefficients of -1, 12, 6, and 80. From that polynomial right there. All the coefficients. If we were skipping any, we'd use 0, but we don't need to skip any because they're all there. And then we're going to bring down our first one, -1, multiply by -5. 12 plus -5 is what? Or 12 minus 5 is what? 7. 7 times 5 is 35. 35 plus 6 is 41. 5 times 41. 205. Plus 80 is 285. So that right there is our remainder, which means that we have 285 and the annual revenue is in thousands of dollars. So after 5 years, we have 285 in thousands, so $285,000. So revenue in year 5 will be $285,000. Okay. Any questions about that one? Maybe about 15 more seconds on that, and then we're going to move on to example 5. Oh, yeah, it's a positive 5. That's just a 5. Yeah. This one was -5, but we added it to the 12 or subtracted from 12 to get 7, but this 5 over here was positive. All right. Next question. We're basically doing the same thing on the next question, but we're actually using the factor theorem to determine, or we're going to use the remainder theorem to determine if the factor theorem can work on this. So basically it's saying, how can you use the factor theorem to determine when the given binomial is a factor? If it is a factor, write the polynomial in factor form. So the factor, if something is or is not a factor, it depends entirely on the remainder. So if there is a remainder, is it a factor? No. Okay. If the remainder is 0, is it a factor? Yes. Okay. So if there's nothing left over, if it divides evenly, remainder of 0, it is a factor. If it's anything other than 0, if there is a remainder other than 0, it's not a factor. So we're basically just doing the same thing again. We're looking at the remainder. If the remainder is a number other than 0, it's not a factor. If the remainder is 0, it is a factor. And if it's a factor, we're going to write the polynomial in factored form. So here we go. What is our value for A on this problem? 6. Good. Because we're no longer just given the value of A, we're given the binomial. So we need the number that makes this equal 0, which is 6. So we're going to say 6. We're going to use synthetic division. We have all of our coefficient values that we need. 1, -8, 16, -23, and -6. So let's write these down. 1, -8, 16, -23, -6. Set up our line, bring down the first one. There's 1. 1 times 6 is 6. Let's work through this. -8 plus 6 is -2. -2 times 6 is -12. 16 minus 12 is 4. 6 times 4 is 24. -23 plus 24 is 1. 1 times 6 is 6. -6 plus 6 is 0.
Yeah.
So is x minus 6 a factor of this? Yes, because the remainder is 0. So what we need to do now, because it's a factor, we are going to write the polynomial in factored form, and we have our count for Spirit Day. So sophomores, pink, purple, or red. Red works too, yeah? Okay. I mean, red's a Valentine's Day color, right? Sophomores, all right. Juniors. All right, juniors now. You get them all?
Yeah.
Okay, seniors? One senior? Cool, thank you. All right. So here we go. If we are going to be writing this in factored form, that means the factors are the thing that we divided by, x minus 6, and the result, x cubed minus 2x squared plus 4x plus 1. So here we go. The answer is x minus 6 times x cubed minus 2x squared plus 4x plus 1. That is factored form. Because if you multiply your divisor by the answer to the quotient, you would get back to the original polynomial. That's what we divided by. That was the answer. Multiply them together, get back to the original polynomial. Any questions about that before we keep going? By the way, you can also use direct substitution. I'm going to show that real quick down here, but most of the time you'll be given an option. If it tells you to determine whether the given binomial is a factor, you could use either synthetic division or direct substitution. So I'm going to show you this other method, and you can use whatever you prefer after this.
Have your attention, please. It's time for group number 4. Group number 4, which are students with last names R through Z. R through Z, please report to the Career Center for testing. Juniors, last names R through Z, please go to the Career Center at this.
Okay. Yeah. So with direct substitution, using direct substitution, all we're going to do is take our value of a, which is 6, and plug it in for x in that polynomial. So if you plug in 6 for x into this polynomial right here, anytime you see x put in a 6, you can just type that directly into your calculator. What do you think the answer should be? Should be 0, yeah. So let's see what happens. Let's see if that works. So we've got 6 to the power of 4 minus 8 times 6 to the power of 3 plus 16 times 6 squared minus 23 times 6 minus 6. That should equal 0. And it does. Because the remainder was 0. X value is 6, Y value is 0. Listen up. This is just another method to show or to check to see if something is a factor or not. So if you end up with an X value of 6 and a Y value of 0, that means that X minus 6 is a factor. So P of 6 is equal to 0. X is 6, Y is 0. Just like we had here. 6 0. Either method is fine. You don't have to do both. So whichever method you feel most comfortable using, that's the one you should probably go with, unless it says to use a specific method. But the answer is the same either way. Questions before we turn the page? All right, anybody need more time here before we move on? Okay, flip it over. This is our last page. We're just about there. So what I'd like you to do is use either method. Use either method to check. Use synthetic division if you want to, or use direct substitution. I don't know why this says synthetic substitution. That should say synthetic division. So. All right. Try this one here on your own. Choose either method, 1 or 2. And there's a reminder to the left. We've talked about this already, but especially for this problem, if you're using synthetic division, remember to include 0 as the coefficient for any missing terms. You might need to do that on this problem if you're using synthetic division. Now, if you're using substitution, you just plug the number in. Make sure you plug in the right number, though, if you're using substitution. Meaning, you're not plugging in 3. Okay. So here's synthetic division. Did anybody use direct substitution? Anybody plug in -3 to the polynomial? Or did everybody go synthetic division? Either way, it's fine. But if you use direct substitution, what number did you get? Choose your method. All right, take a look. Eyes up here, please. Thanks. All right. Answer's -21 either way, right? What does that tell us about the factor situation here? Is x plus 3 a factor of that polynomial? No, why not? Yeah, that's not a 0. That's not a 0. If the remainder is 0 or the result of the substitution is 0, then the binomial is a factor. Otherwise, not a factor. So x plus 3 is not a factor. Because it's not a factor, we do not need to write it in factored form because it's not a factor, therefore it can't be factored. So that's our answer for this one. Couple more problems just like the ones that we did down below here. So using either direct substitution or synthetic division, I want you to answer A and B. Determine if we have factors there. Try A and B. Work on those for a couple minutes. We'll get things wrapped up after that. Use direct substitution or synthetic division, one or the other. You don't need to use both. All right. Give it a try, guys. All right. See what you got. A and B here. Try it. Yeah, you had them. I mean, how come? Oh, no, those are the ones that I put on your desk. They're probably right there. Those are the ones that you got yesterday. Is the first one a factor? Yeah. Okay. So let's go and fill it out. We're saying yes for the first one. So 4 times 1 is 4. Negative 10 plus 4 is negative 6. 4 times negative 6 is negative 24. 28 minus 24 is 4. 4 times 4 is 16. Add them together. 0. Remainder is 0. It's a factor, so we need to write it in factored form because it is a factor. So here's our x squared, here's our x, here's our constant. So we take our original binomial that we divided by, x minus 4, and we multiply it by the quotient, which is x squared minus 6x plus 4. That is the answer for part A. Any questions on A? Remainder 0. This is a factor. That's factored form. Chances are we'll get one of each. So I'm just gonna make an assumption that the next one is not a factor because that's usually how things go. Is it a factor? No. Okay, let's find out. What's the remainder? 5. Is it 5? Okay, let's check it out. So 2 times negative 5 is negative 10. 9 minus 10 is negative 1. That's 5. Bring that down. That's a 3. Negative 15. 6 minus 15 is negative 9. That's 45 and 5. Nice. So x plus 5 is not a factor. There's our answer for part B. X plus 5 is not a factor. Did anybody use the direct substitution method? Maybe just plug in values of X to get a Y value? Yeah, and you got the same answers? 0 and 5? Good. All right. Any questions on either of those? How we feeling? Decent? Okay. Most of what we did was using synthetic division, but there will be problems where you have to use long division as well. Before we wrap up, we got 5 minutes left. Before we wrap up, let's just take a look at this one real quick. It's the same type of question. Is it a factor? If not, what's the remainder? I'm going to use synthetic division on this one. So what's our value that we put in a box? 2. All right. Let's see. 5, 4, 3, 2, 1. No, none at all. So we're not missing any terms. So that's good. So we can say 1, 1, -6, 2, -11, and 15. Bring down the 1. 1 times 2 is 2. 2 plus 1 is 3. 2 times 3 is 6. -6 plus 6 is 0. 2 times 0 is 0. 0 plus 2 is 2. 2 times 2 is 4. -11 plus 4 is -7. 7 times -2 is -14. We got a remainder of 1. It's not a factor. So, not a factor. Okay, that's all I got for you. We got a few minutes left, so let's see.